Okay, so the next problem in the Leet code we are solving is maximum depth of a binary tree. Okay, so here we have given a binary tree and we'll have to find out the maximum depth here. Okay, so in the given problem the depth would be 3. Okay, like meaning 1 2 3. Okay, so how are we going to solve this problem? Like, I mean, we can make use of the breadth first search or the depth first search. Okay, so let me just quickly give an overview about how the breadth first search can be used. Okay, so it's like just an iterating through it. Okay, like, I mean, we can it's like the similar problem where we can right side view of the tree, right? And also the maximum level sum, like, I mean, what is the maximum level sum, those kind of problem it would be. Okay, so we'll be iterating through this and we'll be iterating, I mean, we'll be checking all these nodes at once by knowing the length of the queue, meaning we'll be knowing how many number of elements that are present here, correct? And we'll be iterating all through that, and then we'll be identifying the depth. So we'll just pop all those queue elements and we'll be incrementing the depth and we'll be tracking the count of it. Okay, so this is how we can use the breadth first search by iterating this way. Okay, right, we'll be iterating once, we'll be iterating all the node this, and we'll be making a count of it. Okay, this is the BFS, and the next one is we can make use of the depth first search. Okay, so to understand this will be like little different, right? So what we to scenarize, right? What we'll do is we want to find out the depth here, right? So basically when we come to the depth first search, it's the recursion, correct? We'll be doing some analysis here, and then when we go here we'll have to do the analysis full here, and it's basically the recursion, correct? So how I am going to split this is okay, like this is the node we are at, and it can be currently by just looking at it, right? I cannot left node I mean, sorry, the left node is only one, but right node has grown big, correct? In the other way around, like let's say that left tree might be grown bigger and right tree might be little smaller. Okay, like it can be either way. So what we'll do is we'll do the calculation for both the we'll find the depth for left and as well as the right. Okay, so to just to give an analogy, right? Let's say what we'll do is we are here. Okay, I will ask this guy to find and tell me the max left. Like, I mean, what is the depth inside the water? Let's consider this as a water. Okay, and I will ask as I'm this guy, I will ask this guy to identify and tell me like what is the depth for you, and I will tell this guy to identify the maximum depth and tell. Okay, so similarly, next what these two guys will do is they will also do the same. They will ask the subordinates. Like, okay, they ask them to identify like and calculate the depth and tell me. Okay, so this is how it's a recursion mechanic we can use of. Okay, at the end what will happen when we are here? So when we check, right, there is no node, correct? That is the depth, that is the final depth, correct? So the value will be like, I mean, so there is nothing behind it, so we can just return one, right? Or we can like whatever the value this is, right? Like, I mean, let's say that when we are at the end we can just return a zero here. Okay, when there is nothing, right? Like there is no node or nothing, so the depth will be zero. Like, I mean, there is no further depth. Okay, then we can say that says zero. Okay, and when telling back to this guy, you will have to consider this depth also. Okay, like this guy told zero because that is the last one, right? There is no depth here, but when you're telling back you need to consider this, so we'll add a plus one. Okay, similarly the analogy goes to for this node also or this node also. Okay, so to summarize, right, like, I mean, we'll be having a root node here. Okay, and I will be asking, and this is as we are going to the depth first search, and when we say depth first search, it's mostly the recursion. Okay, so how we are going to break down the big problem into smaller one by and solve it recursively. Okay, so we have this root node and we know that we cannot just depend on left or right, like we need to do the calculation for both. So we'll be calling recursively again, like, I mean, we'll be calling this tree with this node, we'll be calling this again this tree with this node. Okay, recursively we'll be solving it. So it's like telling the subordinates to get me the depth. Okay, like I will be asking this depth, how many depth below you are, or something like that. Okay, and again you will do the same for the subordinates. At the finally when the root is there is nothing, right, we'll say it as zero, we'll send it back as zero. When like, I mean, whenever we got some values, we'll have to add one because we are need to calculate this depth also. Okay, now looking at the code, right? So it will be simple. So max depth is equal to this, if not node, just return zero. Like, I mean, okay, let's come back to this later. Okay, condition, exit condition. Okay, so first I will ask, we'll find out the maximum left depth. Okay, we'll be just calling this recursively by passing the left node. So first we'll pass this, and then once there is nothing, right, again we'll pass the none actually, right? Node, there is nothing, right? Once we go there, Once it is none, we'll be just getting the return 0. And for this one, the output will be 0, right? Like, I mean, it will get 0, but we'll have to consider that depth also, so that we'll be considering the +1. We'll be similarly doing both of the calculations and getting the results. Okay, yeah, that's it. Thank you.